Hello, myself Pratish Kurwal, and this is my long video presentation for the project Case Study in Web Analytics. So, the problem statement itself is to analyze the online traffic of a website in almost a near real time for an e-commerce company because they want you to understand like what is the website behavior of their customers. So, a little bit of background is the online sales in the United States has reached around 10% of the total sales and is expected to grow by 25% by the year 2025. Therefore, for this organization, it is very important to understand the customer behavior on their websites. So, as the number of data increases, they want to know the numbers in almost real time. So, by using Apache Spark and Apache Kafka, I would try to find it out like how can we do this kind of analysis in real time. So for my project, the software and technology I have used is Python Pandas, Python Kafka, Python, PySpark, Matplotlib. So everything with Python 2.7, Apache Spark, Apache Kafka. For visualization, I've been using Apache Superset. And for the preliminary data visualization, I've been using Microsoft Microsoft Power BI. And just for Power BI, I've been using it on Windows 10, and my overall project I've been developing on CentOS 7. So the dataset itself, it was created through Adobe Debugger tool. So this is like whole everyone who comes on a website, they have their unique marketing cloud IDs and like different IDs associated with it, and we can scrape it off directly through our website through web portals and we can just get the data. So in real there are like 161 columns in this data source, but for the whole project I've been reducing it only to 6 columns, and I have two files called as ordersdata.csv. The original file is like 151 MB, which has like all the order info for one website, which I'm reducing it to 10 MB for demonstration purposes. And the click data is like the click stream all together for a website, which is like 10 MB, contains each and every click of a customer on the website. So these are all the descriptions available: uh, visitor ID, session ID, page name, device, event, and date time. So these are just like the data description itself. Now coming to the project overview, I've been performing bunch of 10 steps. So firstly installing all the softwares and servers, scraping off all the data from subsample to for demo purposes, saving it as a CSV file. Once I have all the CSV files, I've been visualizing it on Power BI using the same data, creating a simulation as a producer. Like, so I want to know like whenever someone clicks onto the website, so I'm producing the data as a stream and reading it on a consumer simultaneously, and maybe like on two consumers simultaneously we'll see. Then passing everything from Kafka to Spark, and then combining it all to superset. So this is my end-to-end process, like having CSV, passing that data streams on Kafka streams. Through Kafka, I'm talking to Spark. Once I'm doing all the processing through Spark engine, I will be storing all this data on a disk, combining, doing some ETL for making data ready for visualization engine. So the proposed solution itself was Wise use Spark streaming as well as the Kafka streaming. So Spark has like most popular distributed computing libraries, especially the Spark streaming libraries. And for Kafka, the most important is like the parallelization by using partitioning. Not only this, so when you have like lots of data, a lot of data volumes coming into the system, you want to have like a proper queuing mechanisms to handle a lot of data where you don't lose any data streams. And if you just use Spark streaming, you might lose data. So that's why you want to have something which is effective messaging, and then you can process it through a Spark engine. So this is some preliminary analysis. So what I did was I used Power BI tool and I used my data set of flexdata.csv to understand what time does the customer come to the website and on which platform it is more popular. So with the data visualization, you can see like 12 a.m., 1 a.m., 2 a.m., 3 a.m., 4 a.m. You can see like how many customers, visitor IDs are coming by session. And this is like all the people coming through mobile devices. And these are all the people coming on the desktop devices. It looks like at 3 a.m. to 4 a.m. the traffic goes higher. And this is I'm doing like how many visitors are coming through the device ID, like how many people are coming through handle, how many people are coming on desktop, and they're like low number of Android and iOS. So these all visualizations are available as a Power BI dashboard. Yeah. So my whole code overview. So the major part which I'll be playing is like using passing data as a producer on a Kafka topic and passing it on a consumer side where another stream reading would be happening from Spark, Kafka to Spark, and processing will happen. So I would have like so I am doing like two-step process. So one is like just one single stream. I'm passing it on a topic, and one other stream is just consuming it. But in my second case, what I'm doing is I'm passing the data on one topic and consuming it at two different topics. At consuming it at two different uh, Python scripts, but using the same topic. So I'm using all the same topic, but consuming I have like two consumers available at that time. So looking at the code, so what I'm doing over here is I'm just taking all the orders data, and what I'm trying to do, I'm passing streams every second on that topic. So what I'm reading is like I'm just reading 10 streams every second. I'm passing it on my topic and I'm producing streams as if they would have happened on internet. When someone clicks it, you get like 10 streams per second. It can be a higher number, but for the project I'm just doing a simulation. So I'm not showing all the consumer codes right now, but like this is one of the consumer update state by key. And what I'm doing is I'm trying to read all the Python. So if we go behind, so if you see what I'm doing a Kafka producer. So with the producer stream, I'm sending data on to the topic. Now, if I'm sending a data onto the topic, I need someone to consume that data. So how do I consume it? So once I have all the libraries imported, this is my main part of the code. The code we will see later on in the demo, like how it is running, what it is happening. I'm setting up my Spark context. I'm opening my Spark Kafka stream. So this is a very important part, like where I'm just reading as a create direct stream. So now my data structure is in dstream format, and now I have to do something uh, transformations. So what I have to do is I want to maintain my states because I want to know real-time counts, like how many people are coming onto my website, and I want to have like a real-time counts. So what I'm writing is I'm trying to maintain um, by platform. I'm writing a key value pair and updating state by keys. So what I'm trying to do is like maintaining all the rows of ones, and which I can just aggregate later on whenever I want a particular number. So when I run this code, which we'll see later on in this demo, I would see some producer side results as well as consumer side results. So what I'm doing over here, I'm trying to print it out. So on my console, so what I'm doing is like I'm just printing everything by second, like 10 streams by second. And now my code on the consumer side, what it is doing by device, and I've written some bunch of transformations to have current datetime values device. So what is happening, like there is only one order at this point of time. There from the mobile there are like 571 orders, from desktop there are like 108 orders. So this we already saw from our preliminary data visualizations also, that mobile customers are more as compared to the desktop customers over here. My second results are also there. So what I am doing is like I was trying to filter out on one particular page, and I wanted to know because the business people wanted to know what is the best button or like the place on that page where they can do some kind of optimization and have like more revenue. So from here we can know that people clicking more on check price or something, but like we can see this later on in our demonstration that how it is running. So once everything is being processed, if you remember that we always want to look at store at disk part. So now what I want to do, I want to store everything on disk. So when I write everything on disk, these are generated in form of output directories. These are the folders generated in my output area. And inside that, you would see a lot of part files. And inside the part files, these are just the console printouts I've been writing out on the disk itself. So these are just the part files inside the output dir clicks. So this is all the click stream data. So we will know like what is the click stream going on in that page. So what is the another bigger part is like I have to do a lot of data cleaning after the output has been generated. So once the output had been generated, so it had created like a lot of part files inside the folder itself. So I had to combine all those files. So this is my one of the Python scripts which I've been just doing a data transformation so that I can have data in the form of this. So this looks much more cleaner as compared to what every part file had before. So this is like just so visualizing. So now I want to have the visualization. So if I want to have a visualization, I want to make it cleaner so that I can do a good time series analysis on those kind of data in a real time. So even this, I have been updating it on a regular basis by using cron tab and cron jobs. So this script runs by itself. And finally, once the script has been run, I have been uploading this data automatically on my Apache Superset dashboards. These are the dashboards which I created it by myself. And so these are like real-time analytics dashboard. As soon as the data comes, you see a spike in numbers. So if you see 121, 121 till 129, I have the order count. So you can see the how the order counts are growing as the time period is going. So lessons learned. So lessons learned is like Apache Kafka combined with Spark gives us the computational power to do analysis in the real time because of the partitioning system. That's a bigger pro. And we can produce data streams at one end and we can consume those streams at multiple ends. So just publish it once and you can consume however you want to have. Let's say if there's a BI teams in an organization, they want the same data stream but different views of that data, you can do some kind of thing. The downside of this implementation is the creating of the infrastructure itself, especially making sure when you want to make your Spark and Kafka communicate with each other, you want to make sure you have the right jar files. If there are no jar files currently, you would try to struggle just to make everything communicate with each other. And another challenge is like working on the streaming data, D streams itself. So you want to make sure that you have to convert D streams through RDD, RDD to Spark DF. Otherwise, you want to see like what is the current state, whether are you able to maintain the state or not. So that is another bigger problem or issue which you have to maintain, you have to do. But nonetheless, once the infrastructure has been set up correctly, you can use it for real-time applications. As a result, it has been like widely used, adopted by the industry, especially Netflix, New York Times, Airbnb. At website of Kafka, they popularly say that okay, these companies are using for their real-time analytics engines. So future work. So future work for this project right now, what I am doing is I am storing everything on a disk. But instead of this, there are better options. I can use Apache Druid. So with Druid, the main reason of choosing this database is like it is meant for real-time analytics. It takes lesser space as compared to any other traditional OLAP database. So for example, I was reading a blog where they were saying like in MongoDB, some amount of streams, let's say 1 million streams, I guess 1 million streams were taking around 600 MB, but in Druid it was taking only 60 MB. So it's like really lightweight database. Another thing it's considered as one of the good databases for time series analysis. So this is, as my application is using time series data, I think it's a very good application for using Druid with the Apache Superset app altogether. And even I was reading one of the blogs at Airbnb also they are using Apache Druid with Apache Superset with this whole infrastructure altogether. So thank you. This is my first part, and now after this we'll move to the demo part of the thing.